Hello, welcome to Math with Mr. Dobrescu, to the rescue. Today we are going to solve some exponent problems. And example one we have here, multiply powers with the same base. Yesterday we used some inductive reasoning to come up with some rules and some formulas when we use exponents. And we are going to use those rules today as we practice some of these exponents. So for the first example, 1a, we have 2 to the power of 4 times 2 to the power of 5. And we know that if we have the same base, right, if we multiply numbers that have the same base but different exponents, remember the rule is we keep the base, so the base is 2, so we keep the base and we add the exponents. So we have 4 plus 5, 4 plus 5. And we know that 4 plus 5 is 9. So the final answer is 2 to the power of 9. 2 to the power of 9 is our answer for A. And we used the product of powers property. Remember yesterday we came up with that? So it's called the product. So by the product of powers property. So by the product of powers property, the answer is 2 to the power of 9. Let's take a look at the second example here. We have negative 5 times negative 5 to the power of 6. You see that the first negative 5 is not inside of a parenthesis. So I'm going to tell you, please put a parenthesis around negative 5 in this case. And please add the invisible 1 at the top. So we are adding the exponent of 1 there at the top. We can do that in math because 1 doesn't change the negative 5. Negative 5 is still negative 5 without the 1. And if we put the 1 there for an exponent, it's still negative 5 because negative 5 to the power of 1 is still negative 5. But now as a visual, we can see now that we have the same base, which is negative 5. So the same base, which is negative 5. And now we know that we have to add the exponents 1 plus 6. That's why we added the invisible 1 there. So we have negative 5 in a parenthesis to the power of 1 plus 6. And again, by the product of power property, we can do that. So now the answer is negative 5 to the power of 7. So negative 5 to the power of 7 for B. Again, yesterday we came up with that by using inductive reasoning. Let's take a look at C. We have the same base, which is X. So the same thing, we keep the base and add the exponents. 3 plus 7. So the final answer is X to the power of 10. Okay, let's take a look at another set of examples here. So example 2, now here we are going to find a power of a power. So now remember yesterday, if we had a base raised to an exponent, to a power, raised to another power, the rule we discovered was we keep the base, and in this case, we are going to multiply the exponents. So the base is 3, and now we are multiplying the exponents. 4 times 3, 4 times 3, and 4 times 3 is 12. So the final answer is 3 to the power of 12. And in this case, we use the power of a power property, right? Power, so by the power of a power property. So here, by the power of a power property, the other example was by the product of a power property. Here we have the product, 2 times 2. And in this case here we have power, right? Power of a power property. We can do that. So the final answer is 3 to the power of 12. Let's take a look at the second example here. We have W raised to the power of 5 raised to the power of 4. And remember, we keep the base, which is W. And in this case, we multiply the exponents 5 times 4. 5 times 4. And everyone should know that 5 times 4 is 20. So the answer is y to the power of 20. And finally, let's take a look at example 3 here. Example 3, we have finding a power of a product, right? So in this case, we are going to use the power of a product property. So by the power of a product property. Let's take a look. So by the power of a product. So here we have a product, 2 times x. So we see that 2 and x do not have an exponent. Okay? So please remember that if we have a 2 or any base multiplied together with no exponent in a parenthesis raised to an exponent, each of these base is going to be raised to that exponent. So the answer is going to be 2 to the power of 3, x to the power of 3. Right? So the answer is going to be 2 to the power of 3, x to the power of 3. Now, if you get confused, because some students get a little confused here, you can always put a 1 for the 2 and a 1 for the x as an exponent. And then we can use the other property that we had previous to this property, by the power of a power. So now we can multiply 1 times 3 is 3. So now we have 2 to the power of 1 times 3 and times x to the power of 1 times 3. We can use the other property if you forget this property, right? But you get the same answer because 1 times 3 is 3 and 1 times 3 is 3. And the final answer is still 2 to the power of 3, x to the power of 3. And finally, B, we have 3 as a base times x as a base times y as a base in a parenthesis raised to the power of 2. And again, by the power of a product property, each of these base should be raised to this power. So the final answer should be 3 to the power of 2, x to the power of 2, and y to the power of 2. Final answer. Okay, they are not very complicated. Just please remember those properties that we actually discovered ourselves by doing inductive reasoning. Let's take a look now. A couple of more problems here for practice. And I'm going to give you some time. Think about 3, 4, 5, 10 minutes. Work on these problems and see if you can get the answer. Okay, pause this video now. Work. See if you can get the answer and then check to see if you got the same answer like I got the answer when I'm going to solve it for you right now. Okay, so pause the video, do the problems, and then see if your answers match my answers. Okay, so let's get back here. So example 1, 2, and 3, we are going to use the first property we learned yesterday and today, product of powers property. So here we have the same base, right? 6 is the base. We multiply 6 times 6 with different exponents, and in this case, we are adding the exponents. So the answer would be 6 to the power of 2 plus 46. 6 to the power of 6. Next one. Here we have negative 1 over 2 as the base, right? The same base. So we keep that base, negative 1 over 2. And again, we are going to add the exponents. 3 plus 6 becomes 9. Let's continue. Number 3, we have z to the power of 1. Don't forget to add that invisible 1 there. Times z to the power of 12. Again, the same base. Keep the base. And add the exponents. 1 plus 12 becomes 13. Let's continue now. Now we are going to use the property. It's called power of a power. Power of a power property. And in this case, we keep the base, which is 4. And here we are multiplying. We are going to multiply the exponents. 4 times 3 becomes 12. The same thing for 5. Keep the base, which is y. And then we are going to multiply. 2 times 4 equals 8. Let's continue. The same thing. In this case, the base is negative 4 within a parenthesis. So negative 4. And let's multiply the exponents. 3 times 2, 6. I hope you got the same answers. Let's continue. 7. In this case, we are going to use the power of a product. Power of a product property. So remember, each base stays the same. So we have 5 raised to the power of 4. And then y times y raised to the same power of 4. Okay, we are using that property by the power of a product property. The same thing here. We have a. So it's going to be, the base is a to the power of 5 times b to the power of 5. B to the power of 5, final answer. And finally here we have 0.5, the base, the first base, 0.5 to the power of 2 times m to the power of 2 and times n to the power of 2. I hope you got the same answers, and I hope now you are proficient using those 3 properties we discovered yesterday by doing the inductive reasoning. Thank you all so much for watching, and again, please don't forget to like and subscribe, and please hit that notification button so you'll be notified when I'm going to post more videos. And if you didn't subscribe, please subscribe, and again, share these videos with your friends so more students are going to subscribe and watch these videos. All the best to you, take care, and see you